If you take a matrix and flip it so its rows become columns and its columns become rows, you have performed a matrix transpose. This standard matrix has 2 rows and 3 columns, filled sequentially 1 through 6. Locate the top horizontal row, 1, 2, 3, and the bottom row, 4, 5, 6. We call this matrix A. To transpose it, we write A with a superscript capital T. Mastering this geometric flip is foundational for data science and 3D graphics, as it allows a computer to access and process row-based data as vertical columns. Look at this model showing a diagonal axis running through elements 1 and 5. Textbooks often define a transpose as flipping over the main diagonal, but visualizing that axis is tricky for rectangular shapes like this one, where the numbers overhang. Instead of a single flip, let's break it down into localized rotations. We detach that entire first row, rotate it 90 degrees clockwise, and lock it into place as our very first vertical column. We grab the second horizontal row, rotate it the exact same way, and snap it in right next to the first column. We started with 2 rows and 3 columns. Now we have 3 rows and 2 columns. The operation swaps the matrice's height for its width. Any matrix starting with dimensions m by n will always exit the operation structured as n by m. To see the internal logic at work, we can track the exact mathematical journey of a single element, like the number 6. In our original grid, the 6 sat on the second row and the third column, giving it a coordinate of 2, 3. In our transposed layout, that same number 6 now lives on the third row and the second column, making its new coordinate 3, 2. This reveals a universal algebraic rule for coordinate mapping. Every element starting at position ij will map perfectly to position ji. Here is a tall, narrow matrix with 3 rows and 1 column, holding the numbers 7, 8, and 9. Pause the video and predict exactly what dimensions and shape it will take after a transpose. Applying our ij mapping rule means you do not have to rely on visualizing complex shapes in your head, which eliminates spatial reasoning errors when you are handling large datasets. Let's check your work. Our single vertical column rotates 90 degrees to lock in as a single horizontal row, giving us a 1 by 3 layout. This shows the first universal law. Horizontal structures convert to vertical structures. Second, dimensions invert. An m by n matrix becomes n by m. Third, coordinates reverse. Element ij moves to ji. While the transpose is a mechanical reordering of numbers, it is the process that allows software to pivot and align different datasets while keeping every individual value in its correct relative position.